Hello everyone, welcome to today's video in our PySpark interview series. In this video, we'll be answering a fundamental question: what is Spark context in PySpark? If you are new to PySpark or preparing for interviews, understanding Spark context is essential as it's the core component that connects your PySpark application to the Spark cluster. Stick around as we break down its role and why it's so important for managing resources and executing tasks in a distributed environment. Let's dive in. Introduction to Spark Context. Spark Context is the fundamental entry point for any PySpark application, serving as the bridge between the application and the Spark cluster. It is the core object in the PySpark framework that handles the initialization of a Spark application, making it crucial for starting the data processing workflow. Once Spark context is created, it establishes a connection to the cluster, allowing the application to access the cluster's resources and distribute tasks across multiple nodes for parallel processing. Spark Context is also responsible for resource management. It communicates with the cluster manager to request resources like CPU and memory needed to run the application's tasks. This ensures that the tasks can be executed efficiently across the cluster. Additionally, Spark Context coordinates the execution of transformations and actions applied to RDs or data frames, ensuring that tasks are scheduled and distributed to executors on worker nodes. Without Spark Context, the application cannot interact with the cluster, making it an essential component for running any PySpark job. The key responsibilities of Spark Context: 1. Initialization. Spark Context is responsible for the initialization of the entire Spark application. This involves setting up the environment and establishing a connection between the application and the Spark cluster. Without Spark Context, the PySpark application wouldn't be able to start or interact with the cluster. It prepares the necessary settings and configurations to ensure the smooth execution of the tasks within the Spark ecosystem. 2. Resource management. One of Spark Context's key roles is managing resources across the cluster. It ensures the optimal allocation of memory and CPU to different tasks within the application. By communicating with the cluster manager, Spark Context requests the necessary resources and manages them to maintain efficient execution. This resource management is crucial for handling large datasets and ensuring that tasks are processed quickly and without bottlenecks. 3. Task coordination. Spark Context also coordinates the execution of tasks across the worker nodes. It breaks down the application's work into smaller tasks and assigns them to different nodes for parallel processing. This distributed execution enables Spark to process large datasets efficiently, taking advantage of the cluster's computational power. Spark Context ensures that these tasks are executed in the right order, managing dependencies between them. 4. Cluster communication. Spark Context is the link between the PySpark application and the cluster manager such as Yarn, Mesos, or Kubernetes. It communicates with the cluster manager to request resources, allocate CPU and memory, and distribute tasks across the worker nodes. This communication ensures that the cluster manager is aware of the application's needs and that tasks are assigned to the appropriate nodes for execution. This coordination is vital for ensuring the efficient use of the cluster's resources. Example of Spark context initialization in PySpark. This code demonstrates how to interact with an existing Spark context and perform basic operations on an RDD in PySpark. The first section prints out key details about the existing Spark context, such as the application name sec.appname, the master URL sc.master, and the Spark version being used sc.version. These details help us understand the environment where the PySpark application is running, whether it's a local machine, a cluster managed by Yarn, or another setup like Databricks. Next, the code shows how to create an RDD using sc.parallelize, a method that converts a Python list into an RDD. In this case, the list contains three strings. PySpark is great. RDDD is a fundamental concept, and big data processing. The parallelize method allows Spark to distribute the data across multiple nodes if necessary, enabling parallel processing of large data sets. Once the RDD is created, the code performs several transformations on it. First, the flatmap function is applied to split each line into individual words. This transformation ensures that each word is processed separately. Then, map is used to create key value pairs where each word is the key and the value is 1, representing one occurrence of that word. Finally, reduce-by-key aggregates these key value pairs by summing the values for each word, effectively counting the occurrences of each word across the entire dataset. The result of these transformations is collected back to the driver node using the collect method, which brings the computed data from the worker nodes to the driver program. The final word count results are printed to the console. This basic example demonstrates how PySpark can be used to distribute data and process it in parallel, even with simple operations like word counting. Lastly, it's noted that there's no need to manually stop the Spark context in environments like Databricks, where Spark context is automatically managed by the platform. This makes it convenient for users as they don't need to worry about managing the life cycle of the Spark context in managed environments. And that wraps up our explanation of Spark context in PySpark. We hope this gave you a clearer understanding of how Spark Context acts as the backbone of any PySpark application. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss out on more PySpark content. Stay tuned for more interview prep videos and tutorials. Thanks for watching and see you in the next video.